Today, we are going to teach you how to create some incredibly fantastic transition effects. Take a look at these transitions. The two scenes are almost completely unrelated, yet they complete a very beautiful transition in a stable and marvelous way. How is this achieved? We used a very useful LoRa called camera push-in, which is a LoRa for camera zooming or pushing in. This LoRa is specifically designed for the WAN 2.1 model. It performs exceptionally well in the Tushang video workflow. You can click on Files and Version and download the latest version of the LoRa, as well as its corresponding workflow. The only thing you need to pay attention to here is its trigger word, which is called push-in camera. I have also constructed this workflow on Running Hub. You can access this platform through Running Hub. Running Hub is an excellent online working platform in the CompuWave field. It follows up immediately whenever new models and new technologies appear. You can register for Running Hub using the invitation link in my video description. This will allow you to receive 1,000 free credits. Furthermore, you receive 100 free credits every day you log into Running Hub. This lets you try out your own workflows. Next, let's take a detailed look at how to use this LoRa to achieve a very beautiful transition. We will start by looking at the most basic usage of this LoRa. This is a standard WAN 2.1 workflow. I have an image with its resolution set to 832 by 480. For model loading, we are still using the WAN 2.1i to V14B model, specifically the 408p version. We loaded two LoRa's. One is the WAN 2.1 acceleration LoRa, and the second one is the camera push-in LoRa that we are utilizing today. I set the weight for both of them to 1.0. I used QWN3VL here to generate a detailed text-to-image prompt based on this picture. Then, at the beginning, I added the trigger word pushing camera. That is our final prompt. Then we move into the sampling stage. Since this is WAN 2.1, a standard sampling process is sufficient. The most critical node here is called WAN image to video. In this node, we use the positive condition, the negative condition, and the VAE. Additionally, I connected the clip version output, meaning the reference image is encoded via clip version encoding. Whether you connect this or not is optional. After that, we perform the sampling. We use 8 steps of sampling. The CFG is 1.0, the sampler algorithm is LCM, and the scheduler is simple. This is a very conventional setup. Now let's look at the final effect. It is a very obvious camera push-in animation. We start from a distant position and push the camera all the way to a close-up of the character's face. Of course, ending the workflow here isn't particularly practical. Therefore, I wondered what the effect would be if this workflow was applied to the start and end frames. So, I selected the native VACE workflow of WAN 2.1, aiming primarily to implement a start and end frame transition. Let's take a look at what the improved workflow looks like. Since it is the native workflow, I directly use the native VACE model. We use the same acceleration LoRa and the same camera push-in LoRa. Here are our text encoder and VAE. The resolution is still 832 by 480. I didn't write a particularly complicated prompt here. Since the start and end frames are bound to be two completely unrelated frames, I simply wrote a very generic prompt, dynamic motion and best quality. After that, we proceed to the sampling stage. During sampling, I will use a node called WAN Video VACE Start to End Frame. Note these two pictures. One is a person and the other is a Chinese-style beauty image with a gorgeous background. These two pictures are actually completely unrelated. After we resize them separately, we connect them to the start images and end images. After that, we perform the sampling. The sampling parameters are basically consistent with the previous example. Now let's look at the generated effect. Notice that this transition is very stable. The figure transitions to the second picture in a very smooth manner. However, we find a crucial issue. The second picture does not seem to be fully displayed. The animation appears to be halfway through. I made many attempts. For example, I removed the trim video latent node. This node clips a portion of the video frames. I initially thought that this node was causing the video to be incomplete, but even after I removed it, I found that it was still incomplete. Therefore, we must modify this problem. How do we fix this? I suggest using the following method. We create a new node here called image repeat. This node is a native CompuWave node. We connect it and repeat the image twice. This means the end frame now has two images. We connect these two images to the end image's input. Next, let's resample and check the effect. The sampling is now complete. The overall transition effect is very smooth, and the final image can also be displayed completely. Why does this achieve such an effect? I displayed the image and mask generated by this node. Look, we used two images at the end. Therefore, this essentially provides enhanced guidance here. In the mask area, these two frames are also black. So, using two pictures to set the end frame has a very clear enhancing effect on the end frame, allowing it to display very well. That was a horizontal screen demonstration effect using the same workflow. Let's look at the vertical screen version. The entire workflow remains the same, except that my resolution is now 480 by 832. The first image and the second image are also two completely different scenes. Let's check the transition effect. Overall, the effect is also good. You will notice that all transitions seem to share a certain characteristic. From a visual perspective, they all transition from the left side toward the right side. This is actually the role of this LoRa, providing us with a sensory experience. Since the LoRa itself is a camera push-in effect, but using two images, it cannot achieve the continuous one-shot effect we saw earlier. Therefore, it looks to us as if it is rotating to the right. After all these tests, you will find that this method of processing is still very effective. But many people might have this question: if you don't use this specific node, can I still achieve this effect using a standard 2.1 base workflow? Is there no difference between using this LoRa and not using it? I also tested this for everyone. Look at this effect. This transformation is actually quite messy and disorganized, especially the process of the character changing later on. While we cannot say it lacks any motion effects, overall, first, it is unstable, making it look chaotic. Secondly, the transition and deformation lack any logical progression. Therefore, the perceived quality is poorer. Now compare this to the version we generated, where the character turns their head, a new character appears, or one character transforms into another. The overall camera work is relatively stable, and with this type of change, you can see the dragon head transform into a flower and the person's legs begin to appear in this location. The feeling it gives us is quite smooth. Therefore, although this LoRa might not fulfill the typical function of a camera push-in here, it still plays a significant role in maintaining the overall stability of the transition. So what are you waiting for? Go ahead and try it yourself. Follow me to become someone who understands AI.